Okay, so what we saw yesterday was that idea we could use cross multiplication to basically get rid of the fraction. Right? That was our first step every time. So it's cross multiply, so we don't have problem with fractions anymore. Because then they're easier, right? Well, we can't do that when there's multiple things on one side of the equal sign. Right? So we see all these problems. We're always going to have multiple terms on one side, right? And we're still looking at even like what I may say simpler versions of these, where it's a fraction and then a constant on one side versus we might see sometimes like multiple fractions on one side. Um, so how do we approach that if we can't do what we did yesterday? Right? So something we can do to get rid of fractions is multiply by their denominators. Right? If we think about a really simple problem like x over 3 equals 10, we know to get rid of that fraction, right, the 3, we would just multiply by 3. Right? If I multiply everything by 3, the fraction goes away. Easier problem. Okay? What if we, instead of having x over 3 equals 10, what if instead we have like 2/5 plus x over 3 equals 10? Okay? How do we approach that? How can I get rid of the fractions? One way to think about it, and we know to get rid of the 3, we should multiply by 3. Get rid of the 5, we should the 3 we multiply by 3, so to get rid of the 5, we would multiply by 5, right? Well, if I want to get rid of the 3 and the 5 at the same time, what would I multiply by? Not 8, 15. It's 3 times, it's a division thing, which means that multiplication is the way we have to go. All right, so 3 times 5 is 15. That would be our LCD, the least common denominator. All right, if I wanted to add those, if I wanted to actually add those fractions, I would need to find their least common denominator, and then I could add them. Well, instead of adding the fractions, let's get rid of the fractions. So if we say, hey, I'm going to multiply everything by 15 to get rid of those fractions. So if I multiply this by 15, multiply this by 15, and multiply this by 15, and we have to do it to everything. As long as I do it to everything, it keeps that algebraic balance. We're always so worried about, am I doing the same thing to one side as the other? If I want to multiply one part of the equation by 15, I can multiply the whole equation by 15. That keeps the balance that we need. Well, 2 times 15 is 30, so I'd have 30 over 5. And 15 times x would be 15x, so 15x over 3. And of course, 15 times 10 is 150. And then I would just reduce those fractions. 30 divided by 5 is 6. 15x divided by 3 would be 5x equals 150. And now I can solve that equation instead of the original equation, knowing that it's going to have the same answers because I kept balance. Okay? So we can use this idea of the LCD by multiplying by it to get rid of the fractions as another way of getting rid of fractions, since we can't do cross multiplying. So we're going to be doing this with more complex problems with that same thing. Instead of having just numbers on the bottom, we might have numbers and variables, or we might have expressions on the bottom. We can use that same idea no matter what's on the bottom. Just multiply by the LCD to get rid of those fractions. Okay? So I really want you guys to make sure you're keeping that goal in your head. Like, my goal is to get rid of the fractions. And if you keep that why, it's really going to help you with the how we're going to do that. Okay? Our first step needs to be, how do we get rid of these fractions? And we know to get rid of division, we should multiply by something. Okay? So with like the 3 and the 5 there that I just did, the least common denominator was just their product. 5 times 3 gave me 15. Okay? But 3 and 5 don't have anything in common. Right? They don't have any common factors besides 1. Right? If you start to have things in common, so if instead of 2 over 5, I had like 2 over 8, okay, plus x over 4 equals 10. Instead, I had those as my denominators. 4 and 8 have something in common. Okay? So if I go to look for their LCD, multiplying them is not the way to go. The least common denominator for 4 and 8 is not 32. The smallest thing that both 4 and 8 go into is not what goes into them, Tatum. What do they go into? The smallest thing that 4 and 8 both go into. 8. Okay? There's something that they do share there. they could both go into 8. Okay? So the least common denominator there would be 8. So I would want to multiply everything by 8. If I don't recognize that and I still multiply by 32, the problem is still doable. You're just going to have more reducing to do later. So by finding the LCD, you'll save yourself a step later. If you just find any common denominator, the problem will work. You're just going to have an extra step at the end of reducing. Okay? So 1 times by what they go into, not what goes into them. Right? 4 and 8 both go into 8. Right? Remember what your goal is, Jet. You want to get rid of the denominators. Okay? Multiplying this by 2 is not going to make the denominator go away. Multiplying it by 8 will make that denominator go away. Okay? So just what I want to say, guys, just because you can't find the least common denominator doesn't mean your problem's ruined. Finding any common denominator will address the problem. We'll just have more to do later. Okay? If we want to do this the easiest way possible, we want to find that LCD. So want to look at the denominators and see what can they both go into. Okay? So looking at the denominators, what can they both go into? So notice that 2 of them are x. X and x are both going to go into x. We don't need to worry about 2 x's. We really only need to worry about one of them. Okay? Since 2 of them are the same, we don't need to worry about the other one. Okay? We just need to make sure what are x and 5 both going to go into. Okay? Do x and 5 share anything in common? No. So if they don't have anything in common, then we just multiply them. There's your LCD. Okay? So when they share something, then you have to worry about, can I find something smaller? So since x and 5 have nothing in common, just multiply them. That's the LCD. Okay? So our LCD is 5x. There's something I can multiply x by to get 5x. There's something I can multiply 5 by to get 5x. Okay? Make them both 5x if I wanted to. That's not what we're going to do because our goal is to get rid of the fractions, not make new fractions. So multiply every term. Every term. You can't just multiply parts. If I want to change one part of the problem, I have to change the whole problem the same way. If you don't do that, the problem's going to get messed up. Keep balance. So the way I do that is I put a little 5x here, 5x here. So you guys are going to have to watch your writing from here on out. Like, make sure you're giving yourself some space above. There's obviously different ways to write this. I think I've seen most people do it this way, though. You're going to need a little bit of space above the problem to write. So just kind of be aware as you set up the next problem how to give yourself space for that. Okay? We're going to go ahead and do that multiplication. Now remember, we're not changing the denominator because we're multiplying by 5x over 1. The denominator doesn't change. Okay? So 5x times 15. 5 times 15 is 75. So that'd be 75x over x. 5x times 4 is 20x over 5. And then 5x times 7 is 35x over x. Okay? Why are we doing this? So that our fractions will reduce, because 75x divided by x is just 75. So right now I'm just reducing each of these fractions. (20) and 5 both have 5 in them, so I'm just going to divide, by 5, divide by 5. So 20 divided by 5 is 4x. 5 divided by 5, of course, is 1. So I'll just give you 4x. Plus sign stays there. Equal sign stays there. And those x's in the last term reduce out, so we're just down to 35. So here we have this different looking equation. That's a really simple equation to solve. But because we did the same thing to everything, we have balance. And this equation that we have now and the first equation have the same answer. Take this much simpler equation to solve and know this have the same answer. Because we kept balance. Okay? That's why it's so important you do something to everything. Of course, subtract 75. Simple algebra here. So we have 4x equals negative 40, divide by 4. So x equals negative 10. Of course, we're going to check our answer just like we did yesterday. Same rules apply. You always check your answer back in the original equation. And you always check your answer by just simplifying each side, not by moving stuff across the equal sign. And again, I'm going to go over what it means to be extraneous here because a lot of you didn't seem to catch that yesterday. So checking negative 10, 15 over negative 10 plus 4 over 5 equals 7 over negative 10. So I might be tempted to reduce here, right? 15 and negative 10 have something in common. I can take the 5 out of both of those. That's actually going to cause me a problem, right? Because 15, if I take the 5 out of that, I'm going to end up with a denominator of 2. Then I have 3 different denominators. It's kind of hard to add fractions together. I have 3 different denominators. But if instead I notice right now that 2 of the fractions have a denominator of 10, I can make that third fraction also have a denominator of 10. It's probably much simpler. I'm actually doing something that I wouldn't normally do. I'm noticing that would make the problem easier. Okay, so I'm going to take advantage that these 2 are 10. If I could say, hey, what if that was also a 10? Wouldn't that be easier to check? Rather than trying to make these all the same. That's actually going to be really difficult to make them all a smaller number. So I'm doing something a little bit counterintuitive here, saying, hey, let's just multiply this by 2, multiply that by 2. Right. The other thing I'm going to do is take advantage of that negative doesn't belong to the 10. The negative belongs to the fraction. So I'm going to shift that negative to the top of the fraction rather than have it on the bottom. So negative 15 divided by 10 is the same thing as 15 divided by negative 10. It's the same value. Plus 8 over 10 equals... Again, I'm going to do the same thing on the right side. I'm going to shift that negative to the top because the negative just belongs to the fraction. It doesn't belong to the 10. So negative 15 tenths plus 8 tenths, negative 15 plus 8 is negative 7. Negative 7 tenths. So I'm doing a little bit of fraction manipulation that maybe you guys aren't too aware of that you can do. You don't always just have to reduce. Your goal is to have common denominators, not necessarily the smallest denominator. So I'm trying to take advantage of that. And again, that idea that the negative can float. It can be the numerator, it can be the denominator, it can be off to the side. Just the fraction that can have one negative. It doesn't matter where it is on the fraction. Okay? So we can see our answer came to the same number on both sides. That's good. Okay. Extraneous does not mean if we'd gotten 7 tenths equals negative 7 tenths, that is not extraneous. That was extraneous when we were doing square problems because squaring hides negatives. If I square something, the negative goes away, but when I square root, the negative doesn't reappear. So we saw that the negative could hide when we were squaring. We're not squaring here. Okay? This is not extraneous. A lot of you guys picked this yesterday in the daily point that meant that was extraneous. That's not extraneous. That's wrong. You get down to that and you have 2 different numbers, no matter how they're different. You did something wrong. Either your check is wrong, plugged it in, you just did your math wrong, dropped a sign off, right? Very easy to do. You made a mistake somewhere. That's what it's telling you. Okay? Check is wrong or your answer is wrong. Extraneous comes from the denominator. We're not allowed to divide by 0. If we get 7 over 0 plus 2 equals 3 over 5, you plugged your answer in and made the denominator of one part of the problem 0, That's an extraneous solution because we cannot divide by 0. This undefined value here, that would make the problem extraneous. Okay? If any part of the problem becomes undefined, that's telling you that there was nothing you could do about that. That was just going to happen no matter what. Okay? So just because one part is undefined, the whole thing is wiped out. You could also have multiple parts being undefined and still be extraneous. Like if you had 9 over 0 equals 4 over 0. If you plug your answer back in, you get 9 over 0 equals 4 over 0. That answer was extraneous. There's no way that whatever you plugged in was going to work. Okay. So that's what you're looking for in order to say your answers are extraneous. If it's anything else, that's telling you there's a mistake somewhere. Okay? If you get the same number with different signs, if you get two completely different numbers, that's wrong. Okay? So these things are not extraneous. Ideally, we end up with the same answer. But if we end up here, we know we didn't make a mistake. The problem just wasn't going to work. If we end up here, okay, we made a mistake. Peyton, so one or both? Yeah, some part of the problem has to be undefined in order for it to be extraneous, right? It can be one of the fractions, it could be both fractions. If this one was also a fraction, then all three could be undefined. Yeah, some part of the problem has to be undefined in order for it to be extraneous. So if we look back and say, what answer could we have gotten that would be extraneous in this problem? What value of x wouldn't work here? What value of x would make this equal to 0? If you plugged blank in, the answer would be 0. If we had gotten 0 as an answer, then the denominator would be 0, and that's not okay. That just tells us that that answer is not going to work. Okay? If we'd gotten any other number, it wouldn't have worked. This is the only number that would work. See that from our check that it does work. Okay? But if we'd gotten 0, no way that's going to work, because we can't divide by 0. That's the problem. Okay? The shift in thinking, that's going to be, you guys got to watch out for that. Okay? Let's look at the next one. Make sure you guys are speaking up. My first hour I had a ton of questions. They really want to check, what if this is happening? What if this is happening? Okay, those are really good things to be thinking about. What if I change this little thing? What's going to happen to the problem? Okay? Don't be afraid to ask those questions. So the first thing we want to do is get rid of the denominators. We're going to do that by multiplying by the common denominator. Okay? If that 2 was gone, we would do it just like we did yesterday. Because that 2 is there, it's keeping us from cross-multiplying. Okay? What we can take advantage of here is that the denominators are the same. Right? And we do not need to worry about that 1. The 1's not going to do anything to anything. And multiplying by 1 won't change anything. But because the denominators are the same, right, all I need to multiply by is that one denominator. Kind of like here when we did, and I said, hey, we don't need to worry about that x, because when we worry about this one, it'll get taken care of also. Okay, so because these two are the same, I just had to worry about one of them. So because these two are the same, I just need to worry about one of them. If my denominator is x plus 3, then I just want to multiply by x plus 3. I know that'll cancel. Remember, our goal is to cancel the denominators out. We did this yesterday by cross multiplication. Today we're looking at it in a different way. But our goal is the same. Let's get rid of those denominators, make the problem easier with no fractions. So I'm going to take that LCD, I'm going to multiply this term by that, I'm going to multiply this term by that, I'm going to multiply this term by that. Okay? putting it in parentheses because it's an expression. I want to make sure I'm thinking about distribution when I go to do that, if I need to do it. Okay? So it's a really good idea because this is an expression, like a binomial. Putting it in parentheses is a really good idea. And with a monomial, we don't really need to worry about it. We can do that in our heads pretty easily. Okay? So put it in parentheses when you're doing this. What's our goal? Canceling. If I multiply by x plus 3 and I divide by x plus 3, those cancel. What am I left with? X plus 6. Because that's all coming down at the same time, I'm going to put that in parentheses. Those parentheses there won't end up mattering because that x plus 6 is by itself, but I just want to build this habit for you guys. As we bring multiple things down at the same time, you really should group them together. Okay? Here, the x plus 3 and the doesn't have anything to cancel with because there's nothing being divided. So here we just need to do that multiplication. So we're going to take that 2 times the x plus 3. That's easy enough to do. But again, as I bring it down, I'm going to bring it down together. So that's 2x plus 6. Then I have my minus sign. And on the last term, we're multiplying by x plus 3. We're also dividing by x plus 3. So they cancel, right? That was our goal. How do we cancel those things? So all we're left with there is the 5x plus 12. Again, I'm bringing that all down at once, so it's all going in a group together. And that set of parentheses actually really matters because we're subtracting. We talked about that last semester. You guys talked about that in Algebra 1, that how you subtract here is, can be very tricky. Oftentimes students will say, well, 2x minus 5x, but then they'll say 6 plus 12. They don't pay attention that it's 6 minus 12. We've talked about, hey, maybe you should distribute that negative first to make that easier for yourself. Rewrite the problem with that distributed negative. So that's 2x plus 6 minus 5x, but also minus 12. Right? That 12 is being subtracted. So like terms, I have negative 3x, negative 6. This is all stuff you guys have done many, many times. Okay? On the left side, that x plus 6 just been waiting for us. There's nothing else over there. Right? I don't need those parentheses. It's not being grouped against anything. There's nothing to distribute into it. There's no signs, anything like that. So those parentheses can just go away. But yeah, I think it's just a good habit to build because sometimes the parentheses will matter. Here, they really did matter. These two, they didn't. Sometimes it's hard for you guys to decide, should I put them here? Do they matter right now? Versus if you just put them all down, they'll take care of themselves. If you put parentheses there and they didn't need to be there, they're not going to hurt anything. But if you forget them, they can really mess things up. Good habit just to do it, just to be safe. Of course, we want to solve for x by getting x by itself here. So that gives me what, 4x equals negative 12. So x is negative 3. So I want you guys to see like that goal of getting no fractions, how that equation really became, even at this point, was just so much simpler to solve than where we started. And because we did the same thing to everything, this equation here has the same solution as our first equation, because we kept balance. So let's check that. So we get negative 3 plus 6 over negative 3 plus 3 equals 2 minus 5 times negative 3, which would be negative 15 plus 12 over negative 3 plus 3. So I'm doing a little bit of arithmetic before I, but not too much as I'm plugging it in. And then negative 3 plus 6 is 3. Negative 3 plus 3 is 0. That should set off a little warning light in your head. 2 minus something, so negative 15 plus 12 is negative 3. And negative 3 plus 3 is 0 again. So as soon as we see one of these, that's all that matters, but there are two of them. So we're not allowed to plug a negative 3 in because negative 3 makes the denominator 0. Divided by 0 does not exist. So since this is undefined, that means our answer is actually extraneous. But since our only answer doesn't work, what does that really mean? Can't solve it, otherwise it's known as there's no solution. So our only answer didn't work. We've seen this before. It's not the first time we've seen this. It's been a while. It's been a little while, but our only answer doesn't work means there's no answers. So I talked to you guys yesterday about how this was like, essentially we were finding the place where two curves were going to cross. That's what we were looking for, that point where two curves were crossing. This would just mean that the curves would never cross. They might be like, they're not actually going to be parallel, but you could say they're like parallel curves. They're never going to cross. Okay? So these two curves just would never cross. Okay? Again, this is what it means to be extraneous. This is what you're looking for. See that plugging negative 3 into here would make that 0. Well, can't use negative 3. Yep. Okay. So we're going to get to like this one. Okay. Yeah, we'll get there, Jake. Any other questions here? We're just going to keep looking at little wrinkles, that's all.
How did you get it wrong?
So say like instead of negative 3, we got negative 4, right? Whatever, right? Or positive 3. That's right. So if we plug it in, say, so Jet's asking, what if we got it wrong, right? What would it look like? So if we say we got 3, we dropped our sign off somewhere, right? Real easy mistake to make. So 3 plus 6 is 9 on top. 3 plus 3 is 6 on bottom. 2 minus 5 times 3 is 15 plus 12. 15 plus 12 is 27. 27, and 3 plus 3 is 6. So 9 over 6 is 1.5. 27 divided by 6 is 4.5. So we get 2 minus 4.5, which would be negative 2.5, equals 1.5. So we get two completely different numbers. That means something's bad, right? And it doesn't matter if it's 1.5 and negative 2.5. It doesn't matter if it's 1.5 and negative 1.5. If they're different, it's bad. That's wrong. Every number but negative 3 would do that, something like that in this problem. It would give you two completely different numbers. And then negative 3 also doesn't work, but for a different reason. Okay. Good question, Jet. Peyton, so yeah, do we want to write extraneous or no solution? So in this case, the final answer is that there's no solutions because our only answer is extraneous. So again, normally we have two answers and one of them doesn't work and the other one does work, right? So we can just say, well, this one's extraneous, the other one, here's x is 5, that one works, right? Well, here we have to say, my answer is extraneous, ... Okay, that means there's no answers. So your question would be both. I want you to write both. So Peyton asked, like, should we write extraneous or no solution? It's no solution because it was extraneous. We need to say both things. Again, sometimes you guys have one of each. So good questions. Let's try this one. Yeah, these are difficult problems, guys. I'm definitely not saying these questions are really important that you're asking. Try to make sense of this stuff. Okay? Right? What's our goal? Find a way to cancel the fractions, right? Get rid of those denominators. Our tool here to do that is multiplying by the LCD. Right? What's the smallest thing that both of these denominators are going to go into? So what I need you guys to understand here, this problem is especially visually tricky. Okay? If I say, hey, do these things have anything in common? You might be tempted to say they both have an x. But when I ask you guys to say if there's something in common, that's a multiplication idea. We looked at a problem earlier and I said, hey, do 4 and 8 have something in common? And they do, because they have a common factor. 1 times 4 is 4, 2 times 4 is 8. They had 4 in common. We could mess around with that. But there's nothing I can multiply x by to get x minus 5. There's nothing I can multiply x minus 5 by to get x. How about, do they have something in common? That's a multiplication idea. Do they have a common factor? These do not share anything in common. Okay? So you really got to kind of get your eyes past that, saying that they have an x in common. Okay? These two were both x. They both had an x in common. I can ignore that. These two were both x plus 3. They were exactly the same, right? They shared that common factor of x plus 3. 1 times x plus 3 is x plus 3. They actually have something in common. Okay? There's nothing I can multiply this by to get that. There's nothing I can multiply this by to get that. They don't share anything in common. Which actually makes it easier, because if they don't have anything in common, all we have to do is multiply them. That's our LCD. That first problem I showed you guys, one was 3, one was 5. We just multiplied them and got 15. So if they don't have anything in common, which again is the hard part to see sometimes, the LCD is just their product. Okay? Because if I multiply this by something with an x minus 5 in it, that x minus 5 will cancel. If I multiply this by something with an x in it, that x will cancel. That's our goal, to get these to cancel. This has both an x and an x minus 5 in it. So it will cancel both of those. Okay? And you may be tempted to distribute here. That actually make the problem harder. So actually leaving this factored is the easiest way to deal with this. Okay? Any questions about why that's the LCD? Really got to train your eyes not to see the x and the x minus 5 as being commonality. They are actually different. I remember struggling with that when I was in y'all's seats. Say it again, the second part of your statement, Ellen.
Okay, so why is x in front of you just the x multiplying it by 1 now?
I want to get rid of both denominators. So if I multiply this by x minus 5, it's not going to cancel the x. Like if I take this times x minus 5, I would have 3x minus 15 over x, right? Those x's cannot cancel. So I need a regular x there to do that. So why did I put it in front? Because that's normally we put a monomial in front of a binomial when we write it. There's nothing mathematically about that. It's more for this is how we do it. Like we always put the number in front, or we always put the single thing in front of a parentheses instead of after it. That's the only reason. It doesn't hurt to put it back here. Oh, it wasn't anything about that. It was just the one that had like 3 and then 2 x's. I didn't worry about the second x because it was the same as the first x. It didn't matter which x I was looking at. I could have looked at the second x just as easily as the first one. I just picked the first one because it was the first one. So yeah, had nothing to do with that. So I'm going to multiply everything by x and x minus 5. Okay. Why are we doing this? Keep the why in your head, guys. It makes the how so much simpler. Okay, I'm going to start on the right side because we get to see it better. Okay. Why are we doing this? To cancel the denominators. If I multiply by x and divide by x, those x's cancel. So I'm just left with the 3 times the x minus 5 there. I'm going to go ahead and distribute that, right? 3 times x minus 5 is 3x minus 15. Since I brought it all down together, I'm going to put it in parentheses. Okay. I'm going to do the middle one again just because it shows things a little bit better. Why am I doing this? To cancel that denominator. This multiplication up here will cancel that division down there, and we're left with the 8 and the x. So we got 8x. Now the 1 doesn't have anything to cancel any of that stuff, so all of that stuff is going to act here. I would take 1 times x, which of course is just x, and then I would take that x and distribute it into there. So I get x squared minus 5x. That should be, I'll do blue. Because the x minus 5 canceled the x minus 5. So I just had the 8 and the x. So that gives me 1 times x, which is x, and then x times x, which is x squared, and x times 5, which is negative 5x. Okay. X squared minus 5x. Again, that all came down at the same time, so I put it in parentheses. I could group the 8x if I wanted to, but it's pretty unnecessary to put parentheses around one thing. Okay. If you want to, go for it. Right? Do not hurt anything. Do we need them? Will be the next question. So we saw in the last problem that those parentheses were very helpful because they made sure we distributed that negative here. Well, in front of this set of parentheses, there's just a 1. I don't need those. This set of parentheses is just one thing. I don't need those. This set of parentheses over here, again, is just by itself. So none of the parentheses are hurting us here. We can just ignore them. Okay? So sometimes they're really important. Sometimes they aren't. If you put them there when they're not important, they don't hurt anything. If you don't put them there when they were important, you're probably going to mess something up. So I can just ignore them. Say, well, let's combine those like terms over here on this left side. Negative 5x minus 8x. So x squared minus 13x equals 3x minus 15. Should recognize this from yesterday, right? And from before. Got a square, we got x's. We're going to do some factoring here. Let's push everything to one side so we can factor. So I'm going to move everything towards that x squared. Move everything to the left. So here's our new equation to solve, right? The answers to this equation will be the same as the answers to this equation. This is much easier for us to solve than that. Okay? So it's all about rewriting the problem into an easier form of solving. This really is kind of the key, guys, that you see that we can do this idea of canceling. Why are we multiplying by x and x minus 5 is to cancel that x, and then we're left with just this piece here. Same thing here. Why are we doing that? Is to cancel the x minus 5, and we're just left with these. This is the key to this lesson. You see that we can do this. Anything that's feeling weird about that? Stella, doing okay? Chad, you doing okay? So if we're heading into factoring land, what should we be asking ourselves right now? It's our question that should be tumbling around up there. Okay, what's our AC? Okay, so what do we need to know about 15? You guys should all be asking the same question. You should be asking yourself right now. Jake, what are you asking yourself right now? Okay, so what factors of 15 add up to be negative 16? So what is that? All right, so negative 1, negative 15. Okay, so we need those factors of 15 that add to negative 16. Find that special way of breaking that negative 16 up. So negative 1x will just be negative x, and negative 15x's. Plus 15 equals 0. Cut it in half. X and x both have an x in them. It's x times x, and x times negative 1. I'll drop that 1 off. Negative 15 and 15 both have a negative 15 because that first term's negative. You always take out a negative. 15 times x, and then 15 times negative 1. That's where you stop and say, hey, is it working? If you pick the wrong numbers here, this won't work. Okay? That's why this is a built-in check. Did you pick the right numbers? And x minus 1 and x minus 15 equals 0. So x is 1. X is 15. All right, those are the values that make those 0. Those are our zeros. So we can do one thing really quickly. We can actually check to see really quickly if those are going to be extraneous or not. Doesn't mean they're right if they're not extraneous, but we can see if they're going to be extraneous or not. So you can go back and look and say, what value of x would what would x need to be in order to make this 0? What would x have to be in order for this to be 0? 5. Okay, so 5 wouldn't work. Well, we didn't get 5. So, okay, what would x have to be for this to be 0? 0. We didn't get 0. So neither of our answers are extraneous. That doesn't make them right. We still could have made a mistake, but we know they're not extraneous. So you can check that pretty quickly to see if they're extraneous. You still need to physically check them to see if they're right. Okay, but we can know right off the bat they're not extraneous. And check 1. So 1 minus 8, 1 minus 5 is negative 4, and 3 over 1. So something you guys need to see here, so you have a negative and a minus and a negative. That's going to make a plus, right? Minus negative is a plus. 8 divided by 4 is 2. So that's plus 2, which of course is 3. So 1 works. Okay, so just watch out for that. Double negative there. And checking 15. Let's see, 1 minus 8. 15 minus 5 is 10. Equals 3 over 15. Yeah, I've got 3 different fractions right now. I could try to find a common denominator, or I could just reduce. Okay. I would hope that you guys recognize that this is true. 1 minus 4/5 is 1/5. I'm afraid that some of you guys don't recognize that. You know, but 1 is 5/5 minus 4/5. Really not that confident that you guys are that good at fraction work. Recognize that? You should know that this is true. So I definitely want to, I know we didn't go over any questions from yesterday's homework. I'm expecting you guys will have, a good amount of questions from this homework. We really probably using Thursday as just more practice time on this because this is tough stuff that we're doing right now. I need you guys coming back with questions from yesterday's stuff and from today's stuff. If you're walking in without questions, it's not going to be helpful. Okay. It's good to hear you guys asking things today. Okay. Keep those questions coming. We'll keep working on this stuff on Thursday. But that doesn't mean don't do anything until Thursday. You guys can go. I need that kind of screen. Let's do it. You guys tomorrow, maybe?
Tomorrow, Mr. Baker, for that test, I'm going to enroll you.
I still cannot figure out. I didn't look at you.
How about this? Use the math.
So,
What do you do with math?
motion?
Nothing.
Oh,
Might be you tricked